All right, quarter four starts with chapter 8.1. We've got 2 chapters to do. We're going to be doing about 2 lessons per week, just so you know. And like I said, make sure that you are not late on these things because 2 lessons a week I think is more than manageable. Today's lesson contains a lot of material from previous chapters as well as a concept you should already know about. Multiplying fractions is the most basic concept in terms of operations with fractions. A few general ideas. You're pretty much just combining all the numerators and denominators through multiplication. And to make it easy, you're looking to cancel as much as possible before simplifying. Now, division is also included in this, but division is just multiplication in which you flip the fraction, so we'll talk about all that. But the Algebra 2 portion of this process is that you'll be required to factor in all ways, which is GCF, which means that the factor has, or the expression has something you can pull out. The grouping, which is where you have to say multiplies to be a number, adds to be a number. Difference of squares, difference of cubes. I don't know if you remember that, but you'll want to make sure you study your notes on that. And then anything else that pops up that, again, just might need to be done. Because, again, it is assumed that once you reach chapter 8 that you have an idea on how to do everything that led up to chapter 8. So if you learned before, then you'll be able to learn it again. If you did not learn it, then my suggestion is that you email me so I can try to find the YouTube link to the videos in which I taught the process. I do know that makes some students think, but answering my question by sending me to a video is not helping, but you have to think about it. My response is I cannot help when you're not in the habit of helping yourself. So when you do your job, I can actually do mine. If you did not watch the video, then how can I really help you with anything when I already told you how to do it? Or if you did not take good notes, then how can I help you with that too? So try to refrain from blaming me for anything until you've done everything you're supposed to do. Let's get into chapter 8. And really all we're going to do is just walk through these problems and explain what's going on and see how it works. But for the most part, I'm going to write it this time. But for the most part, what you want to do is just factor everything you can. And I am going to factor fairly fast, especially on questions that are basic. So numbers that multiply to be 40 and subtract to be 3, I believe, are 5 and 8. And because there's nothing in front, I know I can put x minus 5, x plus 8. The reason I know that is because if it makes a positive 3, 8 needs to be positive, 5 needs to be negative. Now, if you need to go through the process on your own, feel free to pause the video. But again, I am working under the assumption that we know how to factor all these things. Multiplies to be 35, subtracts to make 2. To me, is 5 and 7. Because it's a positive 2, it means the 7 must be positive. So it's x minus 5, x plus 7. And then I'm going to cross that out and cross that out because I already changed them. That's one of the methods I usually use. And then 5x plus 35 seems to me to be a GCF where both of these can pull out a 5. So 5 times x plus 7. So that's been rewritten, and x plus 3 is the same. So what I mean by multiplication being a combination, it means that really all we are doing conceptually is putting all these together. So we pretty much have x minus 5, x plus 8, x plus 7, and 5, because all those are on top. And on the bottom we have x minus 5, x plus 7, and x plus 3. And so what you're looking to do in terms of the general idea is cancel anything that is the same, and x plus 7s go away and x minus 5s go away, which means you end up with 5 times x plus 8 all over x plus 3. Now, I'm not sure how the computer wants you to write that out. It might be 5x plus 40 over x plus 3, but that's all that multiplication of rational expressions is. Factor out everything you can, put everything together, which again, you don't really need to put everything together. You could have actually over here just crossed those out and crossed those out and put 5 in front of x plus 8, which is what I'm going to do. But I need you to understand, again, whenever you're multiplying, you're literally just taking all the pieces of the numerator, put them together, all the pieces of the denominator, put them together, and cancel out things and write whatever is left over. So again, that's pretty much what it is. And we have a few of these to go through so that you can actually have a good start on your homework. So like I said, that's the main thing we got to look at. B, again, restrictions. When you do these kinds of problems, the key thing you want to do whenever they talk about restrictions is you want to look at the denominator and say if x minus 5 is a factor, then x cannot equal 5, because putting a 5 in there makes that 0. You also want to say, again, it's pretty much just solving. X plus 7 means that x cannot equal -7, because a -7 would make that 0. And here also x plus 3 means x cannot equal -3, because plugging in -3 also makes that 0, and you cannot have 0 on the bottom. So whenever it talks about restrictions, you are looking for values that you place into the factors on the bottom that make it 0. In all honesty, you're just pretty much setting all your factors equal to 0 and solving those to get your answers there. So that's what they talk about when they ask about the domain. The domain is all real numbers except for 5, -7, and -3. So when they talk about restrictions, that's what it's talking about. So we'll do it on the, I think, first three, which is the one you just saw. And then after that, I'm not going to do it anymore, because again, that's just something you should kind of understand. Or like I said, you could always email me and I can explain it to you. So in this, 9x cannot be factored, so we leave it. But 63x squared and 9x, to me, is a GCF thing, because I see a 9 in both of those, and I can take off an x. So I'm going to take off a 9x and be left with 7x minus 1. And again, I'll cross that out because I don't want to leave that there. But notice, now that we have everything like we want, are there similar things? Yep, 9x on top, 9x on the bottom, which means it's just 1 over 7x minus 1. Now here's the thing, that is your answer, but whenever you go to your domain, you have to go back to your original problem, which means the first thing you can't put here is x to be 0, because 9 times 0, of course, would be 0. The other thing is 7x minus 1. So again, moving that makes that 1, dividing by 7 means it ends up as 1/7. So x can also not equal 1/7. So when they talk about the restrictions or the domain, you have to state that x cannot be 0, x cannot be 1/7, and as long as that happens, you're okay. All right. Simplify, multiply, about the same process anyway. What you're doing is, again, just pretty much simplifying everything down. Multiplies to be 9, adds to be 6. To me, it's 3 and 3. Both of those numbers have to be positive. Again, feel free to pause the video and verify it for yourself. Multiplies to be 15, subtracts to be 2. The only numbers I know that do that would be 5 and 3, which means that I would put z plus 3 and z minus 5. Again, I put the minus 5 because the 2 is negative, and this is no good anymore. And then when you cross this out, these two z plus 3's are going to go away, leaving me with just z plus 3 over z minus 5. And again, the restrictions are, because of this portion of the bottom, z cannot equal -3. Z can also not equal the value that makes this 0, which is 5. So that would be your restrictions there. But this would be the simplified version of it, because the z plus 3's canceled out and left us everything else that we needed. Again, these are all homework problems. Make sure you practice them. Make sure you take good notes. And then when you go to ask your question, make sure you show me what you did so I can try to help you out. Now, this is a division problem. Now, the key thing about division is that it needs to be rewritten, because division is just done by, I guess people say, keep, change, flip. So you change this into multiplication and you flip this one over, but I also see negative exponents, which means it'll probably be more. So I think I'll do that up here. So 2x to the third over 3y squared times 3x to the -7th over 8y to the -3rd. Now, based off of the rules that we learned, the negative exponents need to move. So therefore, it's actually 2x to the third over 3y squared times 3 stays, 8 stays, but y comes up and x goes down. And with that done, now we can look at everything as anything I can cancel on top and bottom. Well, here's the thing. 2 does not cancel with 3, but it does cancel with 8. And when you cancel coefficients, you pretty much just look to say, what can I divide both of these by? And I can divide both of these by 2. So I scribble that out knowing that it will turn into a 1. I cross this out and put a 4 beneath it, because 8 divided by 2 turns into 4. Another thing I usually do is 3x's and 7x's. Remember, you usually subtract it. If I'm going to cross out 3x's altogether, it means all these x's go away, and taking 3 away leaves x to the 4th there. And that's pretty much how I do it. Again, I just leave it in the general area of the fraction, but below it or above it if it's on top. Here, 3 and 3 would both cancel out. And then I have 2y's here, 3y's here. I'm going to take off 2y's, leaving me with just y. And in the end, you look and see what you can put together. Well, all these things on top are gone except for y. and the only thing left on the bottom is 4x to the fourth. So again, it's a organization game. However you get used to doing it will work for you. Just again, make sure you practice this stuff, because again, I'm sure there's easier ways to get through it. I've seen them, I've tried them on my phone, but it does not help you later on when you bump into more complex things. And as I said, this is really just getting you ready for those classes that are definitely going to weed you out if you're not ready. So moving on, again, your restrictions, by the way, it would be that y can't be 0. I guess y can't be 0 because that's on the it ended up on the top, or did it? So x moved up, y moved down, x moved down. Yeah, so x can't be 0 either because it was on the bottom. So your restrictions would be y can't be 0 and x can't be 0. But if for some reason y was down here and not x, then it would just be y can't be 0, because again, you only focus on the bottom, and the 3 and the 8 really have nothing to do because they're always going to be 3 and 8. But getting back to this one, looking for numbers that multiply to be 60 and add to be 23. 3 times 20, as far as what I know. So in order to do this, I'm going to go off to the side. 3 times 20, I'm pretty sure is it, because 3 times 20, yeah. So 4x squared plus 3x plus 20x plus 15, which becomes x times 4x plus 3 plus 5 times 4x plus 3. I don't need to see the whole process to know this turns out being 4x plus 3 times x plus 5. 16x squared minus 9, perfect square, perfect square, perfect square is going to be 4x plus 3, 4x minus 3. Again, I usually just cross those out, but it helps if you have a pencil because you can see it better. Here, multiplies to be negative 30, multiplies to be 36, subtracts to be 9. That's usually how I read that, because that tells you what you're going to do. Here we added to make 23. Here we subtract to make 9. Multiplies to be 36 would be, what, 12 and 3, I think. So if it subtracts, that means the signs are different. So 3 should be negative. So 4x squared minus 3x plus 12x minus 9. Again, feel free to pause the video to verify, but I am just using these skills that I know to use to factor. So x comes out of this with 4x minus 3 plus 3 comes out of this with 4x minus 3. So again, I understand this is going to be 4x minus 3 times x plus 3. And then the last one is multiplies to be 15, subtracts to be 2, which is 3 and 5. Again, for a positive 2, I have to do a negative 3. And there, from there, all you do is look for pairs on top and bottom. So the 4x plus 3's cancel. 4x minus 3's cancel. It looks like the x plus 5's cancel. And that is all. So you end up with the answer of x plus 3 over x minus 3. And that is all. They're not going to ask for restrictions on everything, but if there were, you would set that equal to 0. I believe that's going to be negative 3/4, because remember, you would move the 3, then divide by 4. That would be a positive 3/4. This would be a positive 3. That would be a negative 5. But again, that's just things just in case it pops up. But again, the majority of this is just making sure you get used to doing the process, make sure you get used to the organization of actually performing these steps, and then making sure you're ready for the small tricks that exist. Here again, GCF for me is going to be an n gets pulled out with n minus 1. Here is going to be an n getting pulled out with n minus 7. Again, drawing a small line through that to make sure I don't see that again. And then what ends up going away from me are the n's, which means that n minus 1 over n minus 7 is what I'm left with. Now you need to keep in mind the rules. I guess the best way to think about it is a plus or minus sign is like these two are married, which means that it's not really a true story, but the general idea when someone gets married is that you can no longer just hang out with one, you have to take both. And so therefore, if this was just a 7, let's say it was a 70 over 35 times x plus 1. This 35 is just a 35, which means you can cancel a 70 and a 35. But you cannot touch these numbers unless you take the variables with them, because 7 is attached to n, 1 is attached to n. So if you were going to cancel these, they would have to be the same. Just keep that in mind in case you see something like n plus 4 over n minus 10, to know you cannot touch the 4 and 10 because these are both attached to variables. So the only way I can touch this n plus, or the 4, is if I take the n with it, which means I need another perfect n plus 4 with it. Again, if you have an issue with that, just email it to me. I'll be glad to try to clarify. But again, your general answer was just that, because our n's went away, and we cannot touch the n's. We cannot touch the 1. We cannot touch the 7 individually. Otherwise, we break rules. Now, this is where things get interesting, because when we go to factor this, 60 and 18 GCF-wise, I believe, have a 6 in them. Yes, it does. So it'll be 10 minus 3x. And then these both have a 7 in them, which would be 3x minus 10. Now, here's where things, again, get interesting. You have to be careful about the addition-subtraction rule. And whenever you see this, just think about this part here. 2 plus 3 is equal to the same as 3 plus 2. They both equal 5, which means that if there is a plus sign involved, you can flip these things around and not break a rule. So in other words, if this was 4x plus 1 and 1 plus 4x, you could actually cancel both of those because of the plus sign, because addition allows you to flip them around. In other words, I think it's called commutative property. I do know the rules, I just don't teach them a lot because, again, I don't think the words really make a difference as long as you understand. But what you cannot say is that 3 minus 2 is the same as 2 minus 3, because one of these is 1, the other one is negative 1. So how do I flip it around and keep it the same? I have to flip the sign. And so what I'm looking at is I have a 3x minus 10 and a 10 minus 3x. And these would be the same if I could just move the 3x in front and put the 10 in back. But think about it. If I move the 3x in front, that is a negative 3x and a positive 10, which is the opposite. So what you really have to do here is, and I would just do it in this problem, I would put a negative 1. Actually, I think I'll just put a negative on the 6 and then rewrite this as 3x minus 10, because now that allows me to flip it around. But I cannot flip those around with a subtraction unless I make a negative sign exist, because again, when I'm flipping that around, I am taking this negative. Think about it. Negative times 3x is negative 3x, which is what that was. Negative times negative 10 is positive 10. But once I do that, I can now cancel out my 3x minus 10s and end up with the fraction of negative 6 over 7, because remember, one negative in a fraction makes it negative. So therefore, you'll just put it in front of the fraction, and that is how you'll answer it. Again, just do your best to answer it. If there's an issue, email me, show me your work so I can try to analyze where you might have went wrong, because really what you're trying to do is master the steps. Once you get the steps down, the algebra becomes easy. Here we are looking at multiplies to be 54, subtracts to be 3. Now here's where you can kind of use your context. This looks like it's going to be x minus 6, so I'm assuming 6 is the number that goes into 54. Otherwise, you can't factor this anyway. Isn't 6 times 9 54? Yes. Isn't 9 minus 6 3? Yes, which means that this is probably going to be x minus 6, x plus 9. So that goes away. But again, the issue is we have an x minus 6, we have a 6 minus x, and because of the minus, you can't just flip those around. What I have to do instead is put a negative here, and then I can put x minus 6 here. Again, the negative has to pop up if you're going to flip that around. That now allows me to cancel this out, which then gives me the answer of either negative parentheses x plus 9 or negative x minus 9, or I guess it would be just either one of those, because you really don't want to play games with that too much. But I'm pretty sure a negative parentheses x plus 9 is good. What you don't want to put is negative x plus 9, because if you think about it, this negative distributing would make that negative. So either you're going to have parentheses with a negative in front, or you want to distribute the negative and make sure both of those things switch. Consider the following rectangle. The area is 3a plus 13ab, blah, blah, blah. Its length is blah, blah, blah. Find its width. Now, whenever you have word problems like this, because I need you to see this, and they give you area, it is important that you remember the formula for area that you're going to use, which is area equals length times width. Then you use Algebra 2 level substitution. We have an area which is here. So A, I'm going to substitute for 3a squared plus 13ab plus 4b squared. And it equals length times width, which means it ends up equaling whatever my length is, which is, I'm just going to go ahead and put the w in front, w times 2a plus 8b, because it keeps it simple. Now here's the thing, they want the width, w. So higher level algebra says if we're finding width, first off, whenever it says w in terms of a and b, it means that this should be alone and these variables are okay to be on the other side. If you remember literal equations where we had ugly answers, this is where this comes in. But when you're looking for W, it means I need W to equal something. I don't care what's on the other side, I just know I need W to be there. But the thing is, if I would have multiplied and put 2AW, 8BW, I would have made it worse, because the only W in this problem is here, which means that if I want W by itself, I would just divide by 2A plus 8B. And so that cancels, leaving just W. But of course, we just learned that this probably is not the answer, because it looks to me like this can be factored. So looking at this, again, ignoring the variables, multiplies to be 12, adds to be 13 is 12 and 1. So what I'm going to do is go off to the side somewhere. Actually, I'll just take the back sheet of a paper that I just had and break this down to be 3a squared. And remember, when you split, whatever's in the middle is what you have. So 1ab would just be plus ab. 12ab. Again, if that's the ab, you put ab on both of those, and then plus 4b squared. Again, it's the same process. We found out 1 and 12 are the numbers that multiply to be 12 and add to be 13. You just copy the label for your middle. When we split this, we get to take off an a, and only an a, being left with 3a plus b. Copy the plus. I can take out a 4. Both of these also have 1b, which means I am left with 3a, because 3 divided by that, a comes down, plus b, because your 4 is gone and 1b went away, which means it is just 3a plus b over a plus 4b. That doesn't help me, but if you look down here, 2a and 8b have GCF of 2. Which means, in the end, a plus 4b goes away. And in terms of w, you end up with 3a plus b all over 2 equals w, because those two went away, and this fraction simplified to be that. This is the importance of that problem, because you do get very algebraic problems sometimes with perimeter, with area, and it's important that you know how to handle that stuff and be able to simplify it to where it needs to be. But again, that's the application of what we're learning there, is being able to take those complex things and change them. Same thing. Area of a triangle, it's important for you to understand that area is 1/2 base times height. Notice again, they gave me the area, so it's a squared plus 8ab plus 15b squared equals 1/2 times base, which is a plus, actually I'll put the h first, 1/2 h times a plus 3b. Well, from what I know, if I want h by itself, the first thing I'm going to do is get rid of the a plus 3b. I'll deal with the 2 in just a second, because I don't want to make things crazy and double everything over here, because if you remember, if I want to get rid of this 1/2, I could just multiply both sides by 2. But I think what I'll do first is move the a plus 3b by experience. Remember, I'm going to divide by a plus 3b on both sides. And then factor this. Multiplies to be 15, adds to be 8, would be 3 and 5. So therefore, it's going to be a plus 3b and a plus 5b. That canceling out, giving me a plus 5b only, because that's all gone, equals 1/2 h. And now that I have just that piece, now I can double both sides, again multiplying everything by 2, which means that this side gets multiplied by 2 and this side gets multiplied by 2, meaning 2a plus 10b is equal to my h. But that's really all there is. And I'm not going to work out the last problem because we are coming up on 25 minutes, but I want you to understand what the idea of this problem is, which is you should be able to factor this one. You should be able to factor this one, and this one, and this one. But I would not start the problem because of this division. So really all you would do is copy this as is, copy this fraction as is, send this up to the top, and send that down to the bottom, because that division means turn into a multiplication. Move that up, move that down, and then cancel everything you can to get that answer. So it's not that bad. It's just a problem that's going to test your ability to kind of stay organized. But again, if you have an issue with that, email me. I will talk you through it. But it's the same concept. It's just a matter of having 3 things there instead of 2. But again, the multiplication means this stay, but that changes, and then this flips over with 5x squared on top, 8x squared on the bottom. Factor everything as shown, and then go from there. So good luck with all this stuff, and I will talk to you later. Have a good day.